Hello, everybody. My name is Robert, and I'll be taking this session on the AI offerings from Google. And quickly about myself, I am a Google developer expert for machine learning as well as for the Google Cloud. And for my day job, I work as a data engineer. And what that means is I deal with massive amounts of data. I deal with ingestion, storage, processing, retrieval, as well as machine learning engineering, building models, and deploying models in Google Cloud. Right, so to get started, Google looks at itself as an AI-first company. And what that means is, as opposed to what was done in the past, where you build products and then you try to make the products intelligent, they've moved to a model where you bake the intelligence into the products. And Google has a lot of products. There's typically some misconception around thinking that Google is only about search, but let's not forget that there's Android, there's YouTube, there's Chrome, both the browser as well as the OS. There's Gmail and a host of other products. And all of these products make use of Google's AI models. And it's kind of an understatement when you say Google's AI models, because people think you're talking about maybe 10 or 20. But there are actually thousands of AI models in production at Google. However, not everyone in Google is an AI expert, but they have figured out a way to make it work. And what they've done is they've stratified AI so that it works for essentially everyone who's in computing. And the word that they use for it is democratization. So essentially everyone is expected to be able to use AI at some point in time. So let's start with software engineers, because typically you'll start from what's easiest and then you'll get to what's more difficult. So we'll start with software engineers, and typically software engineers are concerned with building products that we all use, whether it's the operating system, whether it's some web-based application or some mobile application. And the last thing you want to do is tell any software engineer to try and figure out some sort of math. I was a software engineer, and all I wanted to do was build the products that I needed to build at that point in time. So for software engineers, a bunch of tools have been made available. If you're into queries, there's something called BigQuery for data analytics, and there's machine learning baked into that. If you're into building voice assistants, there's something called Dialogflow. If you're into building mobile apps, there's something called Firebase ML Kit. And for the rest of us, there are a bunch of APIs that we can call. So I'll start with Firebase ML Kit. It's available for both Android and iOS developers. It's an SDK that you embed, and you just do your stuff. And ML Kit will handle a bunch of things. On device, it will handle text detection. So you're able to use your camera, take a photo, it will extract text from that. It's able to do face detection. So if you have an image and there are faces, it will give you the bounding boxes, the coordinates of the faces in those images. It will do image labeling for you. So it will tell you up to 1,000 different categories of what objects you have in your images. It'll do barcode scanning, and that's useful for lots of applications out there where you need to scan a barcode and take some sort of action, maybe navigate to a site or make a payment or something. It's useful for language identification, so you can, again, use the phone camera and it will detect what language the text is written in, as well as language translation. Now that's not all. There are a few other features that MLKit provides. You can check the docs for that because it's quite extensive. Now, sometimes what you need to do isn't baked into MLKit, and as a result, there's custom model support. Now, this isn't the domain of software engineers, so you're going to need someone else, like a data scientist or an ML engineer, to build the model and export in a compatible format, which is called TF-Lite. And then that can be imported into Firebase MLKit and baked into the application, and it will run on device. Now, for ML enthusiasts, so people who do not particularly write code for machine learning, but who essentially have more of an interest than software engineers, there's something else called AutoML. It's available on the Google Cloud, and it will let you provide your custom data set, and it will train a model. And MLKit supports AutoML model inference. So what that means is you might have a particular use case where you need to tell the difference between certain objects for computer vision, for example, and you can use your custom images, train a model, and export for AutoML inference, and this again will work on device. So at the end, there'll be a link to Firebase MLKit docs on the internet that you can check out. Now, if you're into SQL, there's something called BigQuery machine learning, and this is pretty neat because it lets you work with stuff that you're used to. Again, you don't need to do any of the math, and you don't need to do any programming. Instead, you just write SQL the way you've always done. It's just a few new lines. You still need to understand what feature engineering is, because at the end of the day, machine learning is about data, and data is about features. With BigQuery ML, you're able to do linear regression, logistic regression, both binary and multi-class, as well as k-means clustering. So again, you need to know what these things are. You don't have to do the math, but you need to at least have the foundation for that. But once you have all of the foundation, BigQuery ML is as simple as this, and you will recognize at least that there is a select statement, there's a from, and there's a where. So we're actually writing SQL. What's new here is the first two lines where you create a model and you specify some options. But beyond that, it's a select statement with a bunch of columns. And once you're done, you're able to, again, do inference by writing more SQL. And now we have something on the fourth line, which is ml.evaluate, and you specify the model which you previously trained. And that's it, really. So learning BigQuery ML is something that could be done in a day if you've been writing SQL. Again, we'll have a link to that at the end. Now, if you're into conversational user interfaces, that's Google Home, Alexa, and the like, then there's Dialogflow. Again, you don't have to do any of the math. You don't have to learn NLP or any of the jargon. You're able to just go out and build your app. It works with both voice and text. The platform will handle all of the transcriptions for you, both to and from voice and text. The product that you end up with at the end of the day will work both on the web, as well as on mobile, as well as with any of the other platforms. So you can actually build something with Dialogflow and export to Facebook Messenger, for instance, create an AI bot. And it's extensively used. It has its own website. We'll add a link to that at the end. And, well, for the rest, there are a bunch of APIs. So the first one is the Cloud Vision API. And it's similar to what you get with MLKit. The difference here is this works quite well for web developers, and you have a bunch of SDKs. You're able to work with different languages. So you can work with Python, with Node.js, and a few others. So when you do vision, you're able to identify objects, classify objects, do things like visual product search. So you're able to take an image, extract details about what's in the image, and carry out certain actions with it. So for example, I have a screenshot of the API. This is directly on the site. So there's a try button on the site. You're able to upload an image, and you can see in a screenshot everything that it supports. So it's able to tell you whether there are any faces in the image, and it detects emotions. It will infer the degree of emotion that it senses in the image. So you're able to use just this for certain types of applications. You can, for instance, build an application to detect whether people are under duress, even if they're looking into the camera, for instance. So in some places, you might have crime taking place at an ATM, for instance. If you have something like this, you're able to detect the face of the person who's trying to use the ATM, and you can choose to shut down if you detect any sort of negative emotion like anger or sorrow or something. Now notice the bar at the top. Beyond faces, we also have labels, web, document, properties, safe search, and JSON. So this is an API. It's meant for software people. So you have JSON. It will always return a JSON response, which you can then parse and do whatever you want to with it. So if you look at the labels, you'll see that it's able to categorize whatever objects it finds in the image into up to 1,000 different categories. In this case, we have technology in the image because it sees computers as well as electronic device. We see fun because there's someone smiling and there are some drinks on the table. It sees play, I don't know why, it sees games, sees recreation, but well, different categories. When you go to safe search, what it does is it will tell you if the image is safe for work or possibly even for the internet. So imagine if you have an online store like a marketplace and people are able to upload various products for sale. You're then able to detect whether inappropriate images are being uploaded onto the site. So you see here, you have things like adult or spoof or medical, violence, and racy. Racy is if you have any body parts that are exposed that are normally not exposed. Violence, of course, is if you have things like blood on the screen or weapons that it detects. Now, a simple example of using the Vision API is up on the screen. And in this case, we're using a Node.js interface. It's pretty straightforward. You instantiate the library, create an instance of an image annotator in this case, and you then upload an image and you have callbacks. And we have the same thing here. In this case, what we're doing is text detection. So for example, you upload an image and then you want to extract the text from it. So like an OCR application, you can get the text from the image and go ahead and do all sorts of things with it. There are other APIs like natural language, for example. So if you take an image that has text in it and extract the text, you're able to use the natural language API to process that text. You're also able to use speech API as well as the text API. So there's text to speech and speech to text. So you can sort of wrap all of these APIs together. You can use them in tandem. You can take an image, extract text from it, convert it to a different language, and then show it to the user. So you could build applications where people go where they don't speak the language and they're still fine. Same thing, you're able to take text and convert to speech. So think of applications for people who have some sort of maybe vision impairment and you want to describe the scene to them as they move around. You can do speech to text, again, for people who have some sort of hearing impairment. Now, all of these support multiple languages, and in the case of voice, you even have multiple voices, male, female, and different languages. The translation API supports up to 100 different languages. We have links to all of these at the end of the slide. Now, for ML enthusiasts, and that's people who want to build their own models, but they're not particularly researchers or ML engineers, we have something called AutoML. And AutoML exists for every variant of the APIs that we've already seen. So there's an AutoML for vision, as well as for speech. And we even have something called AutoML tables for structured data. Now, with AutoML, you're going to need to provide your own data as opposed to the APIs. So the APIs are just pre-trained models that are made available to you on the internet. But with AutoML, what you're saying is, well, I have a particular use case that the APIs don't cover, and so you have to bring your own data to it. AutoML will always start with a baseline layer. So if you get deep into machine learning, you find out that we have all sorts of layers and all sorts of models in deep learning. And AutoML will start with a few state-of-the-art models, and it will extract layers from those and then try different layers against the data that you provide to find suitable ones. And then it will apply something called a Bayesian search to try and improve those layers and start to create various models. And as it's doing that, it's training the models, it's evaluating the models, it's trying to find out which of the models is going to be best for the data that you provide. So the key here is you don't get the same model for different types of data, even in the same domain. So when you change your training data, it's probably going to train a new set of models. At the end of the day, you get ML models, you get APIs that you can use to interact with those models. And if you specify that you want to use those models on the edge, which is that you want to have these models in mobile devices or in a Raspberry Pi or some similar device that might or might not be online at the end of the day, but is essentially constrained, it doesn't have a lot of RAM, it's not a particularly large computer like a laptop or a desktop, then you'll also be able to send those models to Firebase ML Kit and make use of them. And finally, we have products for data scientists, data engineers, machine learning engineers. And the first product that we have is called TensorFlow, which is a numerical computation library. It's popular in the machine learning world, but it's not strictly a machine learning library. It's used for statistics, it's used in physics, and all sorts of fields where you essentially need to add or multiply or divide something. There's also the AI platform. The AI platform is useful for training models on the cloud. So we all have commodity hardware, but these things just don't cut it when you start to do actual machine learning. So the AI platform will let you take any machine learning job and put it on the Google Cloud, use distributed computing for training or hyperparameter tuning, or to serve the model at the end of the day. So for example, all of those APIs that we discussed previously are hosted on Google's AI platform. Now, TensorFlow as a library lets you do all sorts of things. If you're into research, then you have access to low-level APIs. And what that means is you could do all of the math, all of the statistics that you need to do, what you typically would do on paper, in the classroom, in the lab, be able to do it using low-level APIs. You also have high-level APIs, so if you're an ML engineer, you're not trying to find a new optimizer. Instead, you're trying to implement something that some researchers have worked on. Then you'll make use of the high-level APIs. And typically, we have two types of high-level APIs. We have the Keras API, as well as the Estimator API. And we're going to see examples of both very soon. Now, TensorFlow is unique in the machine learning world because it's what Google uses. It's actually built for large-scale stuff, actual real-world stuff. So if you're in the classroom, you typically deal with what we call toy data sets, 30,000 training examples, for instance. But in the real world, you're going to be dealing with hundreds of millions of training examples, sometimes billions of training examples, and it just doesn't scale. If you work with Python, you can't read a file with 100 million records in it. When you train, you have bottlenecks, either at the input stage or at the processing stage. How do you distribute training across 100 computers? Those are things that TensorFlow natively handles. It also is available in multiple languages. So you have it in Python, you have it in Julia, in Swift, as well as JavaScript, and probably a few others that are in here. Support is available on multiple platforms. So you have it for TensorFlow serving, you have it for web as a result of TensorFlow.js. You have it on mobile because of TensorFlow Lite and other edge devices. Now, this is high-level TensorFlow, and you start by doing some imports. So this is written in Python, but we will try to get some JavaScript examples across. So the highlighted region simply shows us doing our imports, and the first thing we do is import TensorFlow. And we're making use of the Keras API at this point, so we import Keras. And there are two types of model approaches. We have a functional approach as well as a sequential approach. Functional is a bit more complicated. If you're dealing with things like skip connections, residual connections, then you're going to be doing functional. Otherwise, you're probably just going to be doing sequential. And we have all sorts of layers, and a very popular type of layer is a dense layer that's a fully connected layer. And on the next line, what we do is we create a sequential model, and once you have a sequential model, all you need to do is add your layers. And on the next line, we see where we add two layers. Both of them are dense. If you've ever done anything with layers, you'll notice that the dense layer with one neuron is essentially going to do some sort of binary classification for us. And when you're done defining your model, you go ahead and compile the model. And when you compile the model, what you do is you specify an optimizer and you specify a loss. And there are all sorts of optimizers and loss functions in TensorFlow. And every one of those is available as a research paper, so you can always go and figure out what it was that was originally published in the research paper, and then you can always look at the code to see what was implemented if you're interested in that sort of thing. And when you're done, you can go ahead and train the model. Now, clearly, in the interest of time and space, certain things are in here. So data which we use for training the model isn't defined here. It needs to be handled somewhere else. As a special case, you need to import and pre-process your model, do your your data, do your feature engineering, and all sorts of things. So data and labels would have been worked on. When you train, you need to specify the number of epochs. That's how many times you want to go over your training example. You need to specify a batch size, and all of these things are called hyperparameters. And while you'll spend a lot of time working on your data, you'll also spend a lot of time doing hyperparameter tuning. And when you have your model, you can finally run predictions. And these predictions, typically what we have here is a lab example where you're passing in the data directly. In production, you're going to need to have some sort of API layer that sits in front of this model that takes the data that you need to run predictions on. And that's where the AI platform comes in, because you can take the model and put it in the cloud, and it will generate an API layer in front. And then that will handle authentication for users who need to access it, and it will also scale. And we have an example of the estimator API on the screen right now. And this is a compressed version of a fully connected network. It's a DNN regressor, so what we're doing here is we're carrying out some sort of regression. Again, we don't show how we create our features and process them before they come in here, but we need to pass that in as the model definition. And what you see in hidden units is we add 3 different layers. The first layer has 300 neurons in it, the second has 100, and the third has 30 neurons. And so these are our hidden layers. And similar to what we did with the Keras API, we also have model training. And we're also able to evaluate the model and run predictions. So when you're done with building your models, you can then go to the AI platform. You can then go to the AI platform and deploy your models. It's scalable, so if there's nobody using the models, it will shut down. And when users resume, it will scale up. It's fully managed. It will handle distributed training for you. It will handle distributed parameter tuning, hyperparameter tuning for you. And it will keep your models safe. So you can be sure that whatever security that is baked into the Google Cloud Platform is automatically available to your models. All right, so we've come to the end, and there are a bunch of links on the slide up, and I'm sure you'll have access to the slides. So feel free to dig into the docs and send any questions across. I'm also happy to answer any questions right now, because we still have some time. Any questions? Okay, thank you.